Okay, so this is the review for our law of sines and laws of cosines and some triangle area, right? We had two formulas. One of them involved the trig, right? It was a trig area formula. And the other one involved Heron's formula. If you knew three sides of your triangle, then you could do some other things with it. Okay, so we are going to start with this first question, finding the measure of angle A. Or no, side A. Remember, lowercase letters represent side lengths. And the side is across from this capital angle. Okay, so we have an angle of 105, so we have a side, and then we have an angle knowledge, and then we have another side knowledge. Okay, so you should know that because of the information that we are given, we can find side A by using the law of cosines. Okay, and this is the formula for the law of cosines. Right, so it's 7 squared plus 11 squared minus 2 times 7 times 11 times the cosine of the angle in between them. Okay, that's what the law of cosines says. And we can use that to find the side across as long as we know the side, two sides, and the angle between them. Right, side, angle, side. Let's just use the law of cosines. Okay, so let's figure that out in our calculator rounding to one decimal. So A equals 14.5 when we round to one decimal. Now, I didn't write this earlier, but it's A squared. I had just written A here for the side length, but it's actually A squared in your law of cosines. 7 squared and 11 squared. So then we finally take the square root of all this stuff, and that's where the 14.5 came from. Okay, now the next part says, what is the measure of angle F? And angle F is down here. So we could do one of two things. We know all three sides, so we could use the law of cosines. But if we believe this angle is an acute angle, and since we have an obtuse angle here, both of these have to be acute angles, we could also use the law of sines to figure out the measure of angle F. So if we take 11 over the sine of F, right, because 11 is across from the angle we're finding, so we set up this proportion, right, this ratio, that would be equal to side A, which we had is 14.5. Remember, that's a rounding decimal, over the sine of 105. So if we know an opposite angle and side ratio, right, we have to know two of these things. And we've calculated A. That allows us to use the law of sines in order to find the measure of angle F. Okay, so we'll cross multiply, we will divide, and then we'll take the inverse sine in order to find the measure of angle F. And we're going to round to the nearest whole degree. So I get an angle of F of 47 degrees. Okay, so here are both of your trig laws for non-right triangles. If you have side, angle, side, we can use the law of cosines. And if we have angle, side, side, right, so we have one group that's across from itself. Ooh, that's why we don't have this in geometry, because we don't have any profanity in geometry. So maybe we'll write it as side, side, angle. Well, too late. Then we can use the law of sines to solve that one. Okay, so moving to the right, find the measure of angle B. Okay, so here we have three sides, right? We have three sides of our triangle. And if we want to find angle B, we are going to use the law of cosines again, but solved for an angle. Okay, so that formula looks like this. So if we're finding angle B, then side B is the thing that's getting subtracted. Okay, that's the important thing to remember. If we're finding angle B, then side B is subtracted in your formula. And if you're finding angle A, then side A would be subtracted. So the angle across, the side across from the angle that we're trying to find is the one that's being subtracted in your formula. So 17 is across from B. So this is going to be 12 squared plus 9 squared minus 17 squared over 2 times 12 times 9. Okay, so you put all that into your calculator, and that will tell us the measure of angle B. So rounding down gives me an angle for B of 107 degrees, which makes sense because 17 is a pretty big side. So we're going to have a pretty big angle. Okay, what else do we need here? Let's come over here for number 3. Find the measure of angle P. So here's angle P. So once again, we have 3 sides, so we're going to set up a law of cosines, I guess, formula, right, and solve this angle for P. So 17 squared plus 10 squared minus 9 squared, right? 9 is across from P, so that is the side that gets subtracted in your formula. Okay, 9 is across, so this one gets subtracted. So rounding, we get an angle for angle P of 25 degrees. Okay, so same as before, when you have 3 sides, you can find an angle by using the law of cosines. Okay, number 4, find the measure of angle theta. Now this is a kind of a tricky one, right? Because once again, we have an angle and then we have 2 sides. So this is a law of cosine, law of sines problem. But law of sines, we could have something that's ambiguous, so we need to test. So the first test is to see, is the opposite side greater than the adjacent side? Okay, so this side is opposite, right? Your angle 37, this is the opposite side. Is that side greater than your adjacent side, which is touching the angle? Yes, 12 is in fact greater than 8. So this tells us that we're only going to have one triangle to solve, right? There's not another triangle that we can make with an opposite side of 12 and an adjacent side of 8. Okay, so in every one of our triangles that we have an angle side-side or side-side angle, if you're so inclined, we need to first check to see how many triangles we can make. And since the opposite is bigger than the adjacent, that means we only have one triangle with this information. So in order to find theta, it would be really nice if I knew this side, right? Or if I knew this angle, right? Because either way, if I knew this side, I could use law of cosines to find that angle. And if I knew this angle W, well, then I can just subtract it from 180. So I think in order to find theta, I'm going to use a law of sines, which means I don't need to find this side, but I'm going to calculate the measure of angle W first. Okay, so I'm going to use the law of sines. W is across from 8, so 8 over the sine of W equals 12 over the sine of 37. Okay, law of sines. We need to have one known ratio. So here we have our known ratio of 12 over sine of 37. Okay, cross multiply, divide, and then inverse sine both sides. Okay, so my calculator says 23.65, so rounding to the nearest degree is 24 degrees. So then my theta, the angle in question, will be 180 minus the 24 that we calculated minus the original 37. Okay, so if we know 2 sides, we can always, or so 2 angles, if we know 2 angles, we can always find the third angle by doing geometry. Okay, that's the easiest way to do it. So theta is going to be 119 degrees for this triangle. Okay, moving on, we have triangle dog that we're going to find the area of. So we need to know 2 things. Either we need to know 3 sides, so we're missing a side here, or we need to have 2 sides and the angle between them. Right, so at the moment, we don't have any information to do either one of them. But just like we said, if we know 2 angles, so one is 50 and one is 30, 180 minus 50 minus 30 means O is 100 degrees. Okay, so we can use the formula 1/2 of AB times the sine of the angle between them in order to find the area of this triangle. Okay, so you have your 2 sides, 11 and 13, and we have 100 degrees between them, so we can use this formula to find the area of our triangle. So my calculator says 70.4 is the area of that triangle. So my units are units squared, whenever we're talking about area. Okay, so make sure if it were inches, it were square inches, or centimeters, square centimeters. And there you go. Okay, Carlos jogged 3 miles down A Street and 5 miles down B Street. How far must he jog to return to his starting point? So we're going to find this, right? We're finding the length of C Street that he jogged. So here we have a side and then an angle and a side. So we can solve this using the law of cosines. 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 120. Okay, you plug all that in your calculator, you take the square root, and we get 7 miles as the distance that he has to jog to get back to his starting point. Okay, so a 15-mile jog, that's not a shabby run for an afternoon or something. I don't know, it'll take me about 6 hours. So there you go, there's the first page for our review. So here is the second page. A bearing problem. A boat leaves port on a bearing of 73 and travels 175 miles. Then the boat turns and travels due north for 125. So 73 degrees is, remember, due north is vertical, right? Due north is straight up. So we're going to draw our compass starting in the lower left. Okay, so here is the port that we are leaving from. So I'm going to label this port. Okay, 73 degrees, so here is due north, right? 0 degrees due north. So we're going to come over 73 degrees, which is somewhere over here. We're going to draw a line that represents 175 miles. Okay, so 200 would be a longer line, 100 would be a shorter line, because you want to make your picture as accurate as you can so that your eyeballs will believe your math. Okay, so that you don't have any discontinuity there. So this is a 73-degree bearing. Right, so talking about geometry, what would this bottom angle down here be? This would be a 17-degree angle because, right, every north, south, east, west has a 90 in the corner. Okay, so from here he turns north. North is straight up for 125. So we want our line to not be as long as it was before, right? Because that represented 175. So this is a shorter line, 125 miles straight up. And then we turn and we come back to our starting point. Okay, so how far is it? We're asked for this blue line. How far is it from where we turned back to port? So in order to figure this out, we need to know what this angle here is, because this is the angle across from the side that we want to calculate. So law of cosines needs, right, a side, an angle, and a side. So let's use our geometry and figure out what the measure of that angle. Okay, so we know that it's 90, as this is 90. So if I could figure out the measure of this angle right here, then we would know what that entire angle is that we need. Okay? So let's come and let's make ourselves a triangle. So let's connect our east compass point to your south compass point. Okay, that's always a 90-degree angle. So I have a right triangle here with one angle of 17 and one angle of 90, which means this angle up here has to be 70 or 90 minus 17, which is 73. Okay, and then once again, right, this is also a 90-degree angle. So 90 minus 73 turns out this is a 17-degree angle right here. So then 17 plus 90, this is a 107-degree angle. Okay, so we use geometry in order to figure out the measure of that angle before we do our law of cosines. So now that we know the angle, x squared equals 175 squared plus 125 squared minus, I gotta move it over some more space, 2 times 175 times 125 times the cosine of 107. Okay, so we plug all that into your calculator, right? Take the square roots, and then that will tell us the distance or the mileage that they have to sail to get from their second turn back to the port. So this is what my calculator got exactly, which we're rounding up to 243. So now comes the hard question. On what bearing must we turn in order to get back to our starting point? So let's talk about bearings real quick. Let me zoom in here on where we're going to be, right? So this is the angle we're talking about. If you put in your compass, right, your compass point is right here. There's north, south, west, and east. The angle we're looking for is how much do we have to turn from due north in order to get there. Okay? Well, I know this is 90 from north to east, and this is 90 from east to south. So that much is 180. So if I could calculate this angle right here and add that to 180, that would give me my bearing, right? How much I have to turn to get back to where I'm going. So this angle is across from the 175. So I could either use the law of cosines to find that angle, because I know it's an acute angle. I could also use the law of sines. Okay, so whichever way you want to do it. I'm going to set up a law of sines proportion real quick, because I know that this is acute. So there's your law of sines proportion. So when we solve this, I get theta equals 44 degrees when I round to no decimals, right? When I round to the nearest whole degree. So 44. So there's two ways we could write this. We could write it as 44 degrees. And we are looking to the west of south. Right? That's one way that we could write this, 44 degrees west of south. Or we could add that to 180, and we could look at our compass at a bearing of 224 degrees. So either one of these is a great way. You write it however you do it best. But if you're going to pick this way, make sure you have your compass points correct. Your west of norths and your north of souths and whatever. 224 is correct, always. So if you're going to do it this way, make sure you have your north, south, east, and wests correct. Okay, what else do we have here? Let's see, what else? Find the area. Okay, here's another area problem. We have side angle side. So we will use the 1/2 side times the sine of the angle between them to find the area of this triangle. And we get 84.6 square inches as the area there. And on number 9, I have 3 sides. Okay, so when I have 3 sides, I'm going to use Heron's formula. And Heron's formula wants me to calculate the semi-perimeter first. So 8 plus 9 plus 6, well, that's the whole perimeter. Semi means half, so we divide it by 2. So I have a semi-perimeter of 11.5. So Heron's formula says take the square root of 4 different products. So it's your semi-perimeter times the difference of your semi-perimeter and every single side. So I do 11.5 minus 9, that's 2.5. I do 11.5 minus 8, and that's 3.5. And I do 11.5 minus 6, that's 5.5. Okay, you throw all those into your calculator all at once, and it gives you the area of 23.5 when I round to 1 decimal square meters. Okay, so it's all about figuring out that semi, or half of the perimeter, right? Semi-circle, half a circle, semi-perimeter, half the perimeter. Okay, so now we have a couple of algebra problems. The area of a triangle is 291. What's the angle between them? Okay, so we know area is 291 equals 1/2 of your sides times the sine of the angle in between them. Okay, so we're going to solve this equation for theta. So a couple of steps. Step number 1, figure out all that, right? That is multiplication. So we can plug this all into a calculator and figure out, we're talking about 330 here. 330 times the sine of theta equals 291, blah, 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 blah. Okay? Next step, divide by 330. Okay, now if your calculator tells you something bigger than 1, that means you have done some gross error somewhere. Okay, so the bottom number of 330 should always be bigger than that top number. And I get 0.8829 blah, 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 blah equals the sine of theta. Okay, so this is a trig equation once again, and if you want to get rid of sine, we have to take the inverse sine. Inverse sine. So we inverse sine 0.888, 0.882, blah, 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 and I get an angle measure of pretty dang close to 62 degrees. So if I'm going to round to 0 decimals, I get an angle of 62. Bless you. Okay, so a little bit of algebra going on here. 11, the same kind of situation. What is the length of the third side? Of course, we would make you do this. So let's draw our triangle. One side is 9.5. One side is 6.8. And we know the area. So if I want to find the third side, I need to calculate the angle across from the third side. Amazing. Then I could use my law of cosines. So I'm going to do the same steps as I did in the previous problem, right? Take this area and set it equal to half of 6.8 times 9.5 times the sine of that angle. Okay, and I'm going to solve this for theta. Okay, let me do that. So 45 is the measure of the angle between them. So now that I know that, I can come back and use my law of cosines in order to find the side across. So 6.8 squared plus 9.5 squared minus 2 times 6.8 times 9.5. Scoot over because this times the cosine of 45. Okay, so if you do that and you plug that all into your calculator, we can find our third side. 6.7 is what I got for that third side. Okay, so multi-step problem. First we have to find the angle before we can find the third side. Okay, some problem solving skills going on there. So speaking of problem solving, number 12, how many triangles can be formed with this information? Okay, so let's review what we had talked about in class. Okay, so the first thing we do is we check out the opposite side compared to the adjacent side. Okay, just like before, if opposite is greater than the adjacent side, we can only have one triangle. Okay, now if it's switched and the opposite side is less than the adjacent side, then we have to do some more work. Okay, we have to first calculate the height. Okay, the height of our triangle, because that really determines if we're going to have any triangles at all, right? Because if the height of your triangle is greater than that opposite side, right, then it's like a swing set and we don't have enough space for our third side to even contact that bottom, and we're going to have no triangles. Okay, so if your height is greater than the opposite side, we have 0 triangles possible. 0 triangles, right? Because it swings, it doesn't even touch. So then the third would be if the height is less than the opposite side, This is your ambiguous case, and we're going to have to find two triangles. Okay, one using the law of sines and the other using geometry. So we're just going to subtract from 180. So let's do that first. How many triangles can we make? Let's draw a picture, right? And I said in class that you should always draw your angle in the lower left. Okay, so if this is your angle of 32, this is A, little a of 15 is across from it. So 15 is your opposite side. And B, 18 is your adjacent side. So that means angle B is down here. Okay, so first check, is the opposite greater than the adjacent side? No, so now we have to do the height. So we know it's not one triangle, so let's do the height. And the height is 18 times the sine of 32. Okay, 18 times sine of 32 is 9.5. Okay, 9.5 is a lot less than 15, which means we have two triangles that we need to solve. Okay, the first triangle is this acute triangle, or rather acute angle B, which we will solve using the law of sines. Right, because we have angle side side, and we can find angle C by doing geometry, and we can find side C by once again doing the law of sines. Okay, so let's do that. I'm going to pause the video and do all that work and come back and show it to you. So here's all the work for your first triangle, right? So this is B, B1, and C1, and little side C1, right, for the first triangle. Okay, law of sines, find angle B, subtract it from 180 to find angle C, and then do the law of sines to find side C. Okay, now your second triangle is even easier. So the second triangle, what we're going to do is angle B2 is 180 minus what we found from B1. Okay, because these make an isosceles triangle. Okay, so angle B, we don't use the law of sines again. It would just give us 39.5. So we subtract it from 180. So angle B is 140.5. Okay, C is done the same way. We subtract the other two from 180. So 32, right? And then 39.5. So the second angle C is 7.5 degrees. And then we will set up and solve another law of sines problem to find little side C. Okay, so we don't change our ratio of 15 over the sine of 32, but what we do is change the sine to 7.5. Okay, so 15 times the sine of 7.5 divided by the sine of 32, rounded to 1 decimal. The second value for C is 3.69 or 3.4. Okay, so when you have two triangles, the first triangle you solve with the law of sines. Okay, and the second triangle is your obtuse triangle, right, where angle B is now an obtuse angle for the second triangle. Okay, so hopefully this has been helpful and you feel like you are more prepared for your test over the law of sines, law of cosines, and area tomorrow.